Welcome on the IMDG code, Handling Dangerous Goods as Cargo. Throughout this module, you will look at the importance of ensuring that dangerous goods are transported under the requirements of the IMDG code. You will see how the IMDG code is applied when conducting activities associated with handling, stowage, segregation, and the documentation of dangerous goods cargo. You'll also learn more about the procedures for dealing with incidents involving dangerous goods. By the end of the module, you'll be able to identify the safety protection requirements for preventing exposure to the hazards presented by dangerous goods. Throughout, you'll also learn how to use the IMDG code. The IMDG code was adopted under SOLAS to ensure dangerous goods are made safe for international transportation by sea. The provisions in the code are based on the UN recommendations on the transport of dangerous goods, a framework of rules for the safe transport of dangerous goods by air, road, rail and sea. This provides international rules that are followed worldwide by shippers, consignees, and those involved in their transport. It requires that goods must be named in a way that is recognized against a list of dangerous goods that are allowed to be transported by sea. They must be packaged in a way that protects the people that handle them, while at the same time preventing damage to the containment or the means of transportation. They must be labelled so that the hazards are understood and the actions to take in the event of leakage, fire or personal illness can be identified. Lastly, their carriage must be documented in a way that the hazards of the dangerous goods are clearly understood. The IMO Maritime Safety Committee keeps the code up to date. They take into account technological developments, changes to chemical classifications, and the related consignment provisions. The 2-year periodical amendments to the UN recommendations on transport of dangerous goods provides the source of most updates in the IMDG code. Dangerous goods come in two general forms: substances and articles. Substances include chemicals, mixtures of chemicals, and substances in solutions in varying concentrations. Articles are items that contain dangerous goods, but may release them in a different form, such as refrigerators or vehicles containing fuel. Gas canisters and aerosols are also considered articles for the purpose of transport. The globally harmonized system of classification and labeling of chemicals, known as GHS, is used for the labeling of hazardous chemicals. It is an internationally agreed system organized by the UN and compatible with the UN Transport of Dangerous Goods system. There are 9 pictograms designed to be used as workplace and transport warnings. These are not to be confused with the transport labels identified in the IMDG code that are used for the transport of hazardous goods and dealt with in this module. These transport labels draw attention to 9 different hazard classes that refer to the danger that the substance or article presents. The number on the label indicates the hazard classification. In some cases, the hazards within a class need to be subdivided into subgroups known as divisions. We know that dangerous goods are materials or items with hazardous properties. We have already said that their handling and transportation needs to be managed due to the hazards dangerous goods present. We also explained that there are transport labels for the different types of hazard or hazard classes. So, it's important for those handling these goods to understand these hazards. Click on each of the icons to learn more about the different hazard classes. Common examples of explosives include ammunition, fireworks, and flares. They have the ability to catch fire and burn rapidly or explode as a consequence of chemical reaction. This reaction is capable of producing gases at temperatures, pressures and speeds that cause catastrophic damage and large amounts of heat and smoke. The dangerous goods can go up in a mass explosion, where the entire body explodes as one, or there may be a serious projectile hazard caused by the conditions of its storage or process of manufacture. Because of the varying explosion effects and sensitivity, there are 6 different divisions of the hazards class. Class 2 common examples include aerosols, propane or butane gas cylinders and fire extinguishers. Those include compressed, liquefied, dissolved and refrigerated liquefied gases, as well as mixtures of gases with vapors of substances. Gases can pose serious hazards due to their flammability, potential as asphyxiates, ability to oxidize and their toxicity or corrosiveness to humans. There are 3 different divisions of the hazards class. Common examples of Class 3. Flammable liquids include adhesives, paints, and perfumery products. Those are liquids, mixtures of liquids, or liquids containing solids in solution or suspension that have a flashpoint temperature 60 degrees Celsius or below and give off flammable vapor at ambient temperature. Flammable liquids can pose serious hazards due to their volatility, combustibility, and potential to cause rapid flame growth. Common examples of Class 4. Flammable solids include firelighters, matches, and alkali metals, such as sodium or potassium. Flammable solids are materials that are readily combustible under transport conditions. This may be due to self-reaction, spontaneous combustion, friction, exposure to air, or contact with water. Flammable solids pose serious hazards because of their volatility, combustibility, and potential to cause significant flame growth once they ignite. There are 3 different divisions of the hazards class. Oxidizing substances can be liquid or solid and are not necessarily combustible in themselves. Common examples include oxygen generators and ammonium nitrate fertilizers. Oxidizing substances are found in chemicals in the organic peroxide group, such as benzoyl peroxide. They give out oxygen during a chemical reaction, and this can contribute significantly to the combustion of other materials nearby. Class 5 also includes organic peroxides. These are thermally unstable and can give out a lot of heat while undergoing an exothermic reaction. Organic peroxides must be transported under temperature control because they burn violently with almost explosive force when triggered by impact or friction. Exposure to organic peroxides can also cause eye damage. Toxic and infectious substances can pose significant risks to human and animal health upon contact. Common examples of toxic substances include tear gas, mercury compounds, and pesticides. They can cause harm to health, serious injury, and death when swallowed, inhaled, or in contact with skin. Common examples of infectious substances include medical, biomedical, or clinical waste and medical cultures. They can reasonably be expected to contain bacterium, viruses, or other microorganisms that can cause disease. Other hazards presented by dangerous goods include leakage of goods onto the ship's structure, causing it to be damaged or weakened, and leaking into the sea, polluting the marine environment and causing widespread damage to the local marine ecosystem. There might also be chemical reactions with other dangerous goods. They might become chemically unstable, or incompatible goods could react with water, all of which can generate heat, fire, and toxic vapors. The IMDG code can be used in different ways, depending on the function or role of the user. In this module, we are only dealing with receiving dangerous cargo, planning the stowage of dangerous goods, documentation, emergency procedures, and other main activities concerned with safe sea transport. The IMDG code is structured so that the user can start at the dangerous goods list, which contains information and codes that take the user to various provisions and instructions. The IMDG code consists of 7 parts, appendices, and a supplement. Although available in electronic, internet and intranet version, the traditional book form is in 2 volumes and the supplement. Volume 1 contains parts 1, 2, 4, 5, 6, and 7, as well as the packing instructions. Volume 2 contains part 3 and the appendices. The supplement is contained within a separate volume. Now that we know what is included in the IMDG code, let's take a closer look at each of the different parts relevant to transport of dangerous goods by sea. Part 1 outlines the relevant international regulations and defines any substance that is forbidden for transport under the IMDG code. Part 2 deals with how dangerous goods are identified and referenced using what is referred to as a proper shipping name, or PSN, a reference known as UN number, and a packing group that indicates the degree of danger. Part 2 explains the classification of dangerous goods into the hazard types in more detail. Part 3 contains the dangerous goods list, which is key to finding out more information about dangerous goods when the PSN or UN number is known. This part also includes details about how dangerous goods in smaller quantities, called limited and accepted quantities, are prepared for transport. Part 4 provides details about the way dangerous goods are packed. Its real relevance for sea transportation is the explanation of the requirements for portable tanks and multi-element gas containers, or MEGCs. Part 5 covers the requirements for the safe transport of dangerous goods consignments, including procedures for marking, labeling, and placarding. It also explains the documentation requirements. Part 7 is concerned with stowage and segregation arrangements. This part provides details about how incompatible consignments of dangerous goods are segregated on container, ro-ro, and general cargo ships. The appendix lists the UN number and proper shipping names of more general substances that do not have a specific name. The IMDG code deals with these by naming them generally and adding the letters NOS, meaning not otherwise specified. Lastly, we have the supplement. This includes the Emergency Response Procedures, or EMS Guide, and the Medical First Aid Guide. It also includes mandatory reporting procedures in case dangerous goods leak or are lost overboard. It also includes reporting procedures, recommendations for the safe use of pesticides on ships, and the INF code. Now that we know more about how the IMDG code is structured, let's focus on the key parts of the IMDG code, the Dangerous Goods List, or DGL. The traditional book version of the DGL is in Volume 2 of the IMDG code. For further information, it requires the user to refer to the part and section reference shown below the column number. Internet, intranet and CD versions use a data form with the text and numbers and links in blue. Clicking links will take the user to the relevant parts of the instructions or table within the IMDG code. This format uses data fields labeled according to the traditional book version of the Dangerous Goods list. Throughout the module, we will refer to these data fields as column numbers, following the traditional format. The Dangerous Goods list is divided into 18 columns that show specific information. However, for our purposes, we are only interested in 9 of these. Columns 1, 2, 3, 4, 13, 15, 16A, 16B, and 17. Columns 1 and 18 show the UN number. Column 2 shows the proper shipping name, which is always shown in uppercase letters. It may be followed by additional descriptive text. Column 3 shows the class or division of the dangerous goods. Column 4 identifies any subsidiary hazard by its class or division. If the substance is a marine pollutant, it is identified by the letter P. Column 13 contains T codes applicable to the transport of dangerous goods in portable tanks and road tank vehicles. We will explain more about T codes later on in the module. Column 15 contains 2 codes referring to guidance to be used in the event of spillage or fire. These codes are known as emergency schedules. The first EMS code refers to the fire schedule. The second EMS code refers to the spillage schedule. Column 16A contains the stowage and handling codes. Column 16B contains the segregation codes starting with the letters SG, and segregation groups starting with the letters SGG. Column 17 contains properties of and observations on the dangerous goods listed. Earlier, we looked at how dangerous goods can be made safe for transportation. This includes ensuring they are properly labelled so that people handling them can recognise the possible hazards. Anyone handling dangerous goods must be able to determine whether packaging, bulk containers or cargo transport units are labelled, marked and placarded in accordance with the IMDG code. While those on board will not typically interface with packages, it's important to recognise whether packaging is correctly labelled as part of the hazard assessment, particularly in an emergency. However, in any event, any cargo units containing dangerous goods that are not labelled or marked in accordance with the IMDG code must be rejected. There are a number of marks that are required to be shown on all packaging containing dangerous goods. This includes the proper shipping name and the UN number. A hazard class label, including a separate hazard class label for any subsidiary risk, and a marine pollutant mark if the subsidiary risk of the dangerous good shows that the substance is a marine pollutant. Packages containing dangerous goods must also be marked with the consignee or consigner and orientation arrows, if appropriate. If the package weighs more than 50 kilograms, the weight must be shown. So far, we've looked at the essential signage, but consignments need to have special markings in certain circumstances. Sometimes, packages of dangerous goods of the same type from a single consignor are packed in a single outer package for convenience. This is called an overpack. It has to be labelled prominently with the word overpack in large letters. The IMDG code makes special provisions for dangerous goods carried in small unit quantities because of the reduced risk they pose. These are called limited and accepted quantities. If you are unfamiliar with either term, both are explained in the glossary. Dangerous goods carried in limited quantities must carry this mark. A hazard class label is not required. Dangerous goods carried in accepted quantities must carry this mark. Where the accepted mark is shown, this must include the hazard class and consignee. Again, the hazard class label is not displayed. Other labels are required for other dangerous goods. Packages or articles containing lithium batteries or cells must be carried with this mark, while dangerous goods of Class 1.4 and Class 7 have specific requirements. These can be found in Part 4. Now that we've considered the markings on packagings, let's look at the markings we expect to see on cargo transport units and bulk containers. The types of cargo transport units typically seen on ships are shipping containers, portable tanks, and freight trucks and trailers. Containers and freight trucks and trailers must carry a larger hazard class label for each class of dangerous goods carried. These are called placards. They should be waterproof, readily visible, and not faded or damaged. An additional placard should be displayed when there is a subsidiary hazard associated with the dangerous goods inside. A placard showing the marine pollution mark must be displayed if the dangerous goods are marine pollutants. The placards must be clearly displayed at each side and each end of the container or freight truck. Portable tank containers or tank cargo transport units need only display the placards at each side. Cargo transport units only containing goods in limited quantities must display a placard showing the limited quantities mark. The hazard class placard is not required. In addition to the placarding we've just seen, there are situations where bulk containers and cargo transport units must carry other markings. The proper shipping name and UN number must always be displayed prominently on each side of portable tank containers and bulk containers. Characters must be at least 65 mm high and in a contrasting color to the background. On portable tank units of less than 3,000 liters, characters may be reduced to 12 mm high. There are also situations where cargo transport units must be marked with the proper shipping name and/or UN number. Details can be found in the IMDG code in Part 5, Chapter 3. UN numbers must be displayed in one of two ways. They can be black on a white background, 65 mm high, and displayed on the hazard label. Or the UN number can be displayed in an orange rectangular panel next to the hazard class placard. In situations where cargo transport units contain dangerous goods carried at high temperature, the elevated temperature mark must be shown on each end and side of the unit. High temperature means greater than 100 degrees Celsius for liquids and 240 degrees Celsius for solids. In this chapter, we've looked at the signage related to the contents of the packaging, bulk containers, and cargo transport units. Now let's consider how those on board can determine whether portable tank containers meet the IMDG code requirements. There are 25 different portable tank container standards, and the IMDG code specifies the types of portable tank container to be used for particular dangerous goods. Each standard is given an alphanumeric T-code. Each T-code specifies the test pressure, minimum shell thickness, pressure relief valve setting, and number of bottom openings. The details are found in Part 4, Chapter 5. For more information on portable tank container signage, see Learning Film 2550. Portable tanks carrying dangerous goods. The T-code can be found before or after the words UN portable tank container on the side of the container. Here we see a T11 portable tank container. In some cases, the T-code might be found on the plate showing details about the tank container. When there is doubt about the suitability of a portable tank container, you can check that it is suitable for the dangerous goods by consulting the dangerous goods list. Column 13 shows suitable T-codes that can be checked against the portable tank container. Let's consider an example. You receive a consignment of tetrachlorethyl, UN 1897, carried in a portable tank container. Under column 13, we see that if this consignment needs to be carried in bulk, it must be carried in a portable tank container, meeting the requirements of T4. However, as you can see, carriage in tank containers with a higher T code as shown in the table in Part 4, Chapter 5, is also permitted. It's essential to recognize the importance of correct stowage and segregation of incompatible dangerous goods. The concern is always leakage or escape of dangerous goods due to damaged or inadequate packaging, or when poorly stowed cargo moves with vessel's motion. This can cause injury or illness to crew and passengers if stowed near the accommodation. Incompatible dangerous goods could also react with each other, possibly resulting in a catastrophic accident, such as a fire. The IMDG code details specific stowage and segregation requirements by the use of codes and references in columns 16A and 16B of the dangerous goods list. There are also more general segregation requirements based on hazard classes in a segregation table that can be found in Part 7, Chapter 2. Before we look at stowage, handling and segregation in more detail, it is important to understand that the ship's design will restrict where certain classes of dangerous goods can be stowed. This is due to the hazards presented and the availability of systems to deal with any emergency. Ships that have cargo spaces intended for the carriage of dangerous goods must carry a document of compliance, which certifies that the ship meets SOLAS requirements for these cargoes. The annex or schedule to this document specifies the restrictions for their stowage within the cargo area. This usually comes in the form of a matrix that allows the cargo officer to determine which hazard class can be stowed where. Dangerous goods classifications are entered in the rows of the table. Numbers representing cargo spaces are entered in the columns. The number of the cargo space is indicated in a simple diagram of the ship and refers to a cargo hold or deck cargo stowage area. The table shown is typical and is populated with either the letter P for permitted or X for not permitted. Alternatively, the words yes and no may be used. We've just considered stowage based upon the limitations imposed by the ship. Now let's look at the stowage requirements based on the dangerous goods list. If there are any particular stowage requirements, these will be shown in column 16A of the dangerous goods list, which will contain alphanumeric codes that can be used to reference any particular stowage requirement. There are 3 different codes that could be displayed. It may be a stowage category code. These codes specify whether goods can be stowed on deck or under deck, under what conditions, and the particular requirements if passengers are carried. The codes are either letters A to E for all hazard classes except hazard class 1, or numbers 1 to 5 for explosives. It may be a stowage code consisting of SW followed by 1 or 2 numbers. These codes refer to descriptions of very specific stowage requirements. They may include ventilation requirements or additional safety precautions. It may also be a handling code consisting of H followed by a single digit. This code refers to the conditions under which the consignment of dangerous goods is transported. We've just looked at the document of compliance and column 16A of the dangerous goods list, which identifies where and under what conditions dangerous goods can be stowed. Now, let's consider column 16B of the dangerous goods list. This may display 1 or 2 alphanumeric codes that refer to specific segregation requirements based on a particular substance. A segregation group consisting of SGG followed by 1 or 2 numbers classifies substances into groups having similar chemical properties. A segregation code consisting of SG followed by 1 or 2 numbers refers to the segregation requirement from other segregation groups. You can find more information in Part 7, Chapter 2. Now that we know what we're looking for, let's try an exercise. Use the dangerous goods list to determine the segregation group and segregation codes for UN 1824 sodium hydroxide solution. Did you get SGG18 and SG35? If you did, well done. If you got something different, now that we have the segregation code for UN 1824 sodium hydroxide solution, let's see how we can use it to determine segregation requirements. In Part 7, Chapter 2 of the IMDG code, the segregation group table describes SGG18 as alkalis. This means sodium hydroxide is included in a group called alkalis. The segregation codes table describes code SG35 as stow separated from the segregation group acids. If we look at the table of other stowage codes, we notice other terms used to identify the levels of separation. Each term starts with the words away from or separated from. The IMDG code identifies 4 segregation requirements. These are away from, separated by a complete compartment or hold from, and separated longitudinally by an intervening complete compartment or hold from. The actual definition of these terms depends on the ship type. These are specified in Part 7 of the IMDG code. Chapter 4 deals with container ships, Chapter 5 deals with ro-ro vessels, and Chapter 6 deals with general cargo ships. We will look at each of these in more detail a little later in the module. Before we look at how the level of segregation is specified for different ship types, let's take a few minutes to understand how we can determine the actual segregation requirement between incompatible classes of dangerous goods. The level of segregation between 2 dangerous goods of different hazard classes or divisions can be determined using the segregation table shown in Part 7, Chapter 2. The rows and columns are labelled with different hazard class or division. You can determine the segregation degree by entering the table with the different hazard class or division. Where X appears, you must consult the relevant section of the IMDG code. However, the segregation requirement must take any subsidiary hazard into consideration. The highest level of segregation must always be used. For example, if you want to know the level of segregation between substances from hazard class 4.2 and 5.2, entering the segregation table tells you that segregation 2, separated from, is required. Now that you've seen how to determine the different level of segregation, let's take a look at how you interpret these for different ship types, starting with container ships. Part 7, Chapter 4 of the IMDG code provides tables for the user to determine the horizontal and vertical segregation requirements for container ships fitted with hatches and those that are not. The segregation requirements 1, 2 and 3 are defined for closed and open containers for vertical separation and horizontal segregation. Vertical separation states whether containers are permitted on top of one another or in the same vertical line. Horizontal segregation states the container space is required. In some cases, this may include bulkhead separation requirements. The requirements for segregation level 4 are a little different. Vertical segregation and horizontal athwartship segregation is not permitted. Horizontal fore and aft segregation is based on a minimum distance of 24 meters and possibly a minimum number of bulkheads. Illustrations regarding the segregation requirements are shown in IMO Marine Safety Committee Circular 1440. Which can be found in the supplement to the IMDG code. Here is a simplified version of open versus closed containers on a container ship fitted with hatches. Part 7, Chapter 5 provides a table for the user to determine the horizontal segregation of cargo transport units on ro-ro vessels. As with container ships, there is a table specifying the segregation requirements based on the 4 segregation groups defined earlier. The table identifies the segregation requirements for athwartships and fore and aft for both closed and open cargo transport units. The segregation requirements are specified in terms of distance, bulkheads, and whether on deck or under deck. Again, illustrations regarding the segregation requirements are shown in IMO Marine Safety Committee Circular 1440. In the supplement to the IMDG code. Part 7, Chapter 6 of the IMDG code applies to segregation of packaged dangerous goods stowed in the conventional way. This includes particular segregation from foodstuffs. The different segregation requirements are specified in terms of horizontal distance and vertical separation from packages containing incompatible dangerous goods. This takes into account any fire and liquid-resistant compartments when considering vertical segregation. Where dangerous goods in packages are stowed together with a cargo transport unit containing dangerous goods, no segregation between the packages and the cargo transport is needed when away from is required. Where separated from is required, the segregation for away from is sufficient. Where segregation between packaged dangerous goods and those carried in bulk under the IMBSC code, the segregation requirements are specified in a table similar to the segregation table specified earlier. The definitions of the 4 segregation terms are also defined for such a stowage arrangement in a similar way as described earlier in this section. Now that you understand how the IMDG code helps you to handle dangerous goods, let's take a look at the documentation required to ensure dangerous goods are transported safely. The information contained within various documents allows the cargo officer to check that the consignment is ready for transportation in compliance with the IMDG code. As the documentation contains important information about the hazards and the safe handling of dangerous goods, it is essential that officers are aware of the different documents and what they contain. As required by SOLAS, every ship carrying dangerous goods in package form must have an up-to-date special list, manifest or detailed stowage plan that identifies the dangerous goods, the hazards they represent on board, and where they are located. These documents must follow the provisions set out in Part 5, Chapter 4 of the IMDG Code, and a copy must be made available to the port authorities or Port State Control Officer. MARPL Annex 3 requires any description of dangerous goods to include the words marine pollutant if they have such a subsidiary hazard. Let's take a closer look at the transport documents required to be carried on board when loading dangerous goods. In addition to other documentary requirements, it is essential that emergency information is included. This may be shown as appropriate entries in the Special List, Manifest, and Dangerous Goods Declaration or Multimodal Dangerous Goods forms. Alternatively, it could be presented by the provision of a separate document, such as a safety data sheet, or through other separate documentation provided by the shippers. In certain circumstances, other special certificates or instructions may be required depending on the hazards. All dangerous goods transportation information must be retained for 3 months. Now that we've looked at handling, stowage and the segregation requirements of dangerous goods, Let's consider how crew members should respond to an incident involving dangerous goods. Included in the supplement to the IMDG code, the Emergency Schedule or EMS consists of a series of tables or schedules that provide guidance for emergency response procedures. The tables cover spillage and fire. The emergency schedules for spillage consists of 26 tables, each for different types of hazardous substance, ranging from SA, toxic substances, to SZ, toxic explosives. There are 10 emergency schedules for fire, including FA, which is the general schedule. The other 9 are specific to fires associated with various hazard classes. It is important that the general guidelines for fire and spillage described in the EMS guide are also consulted when using the emergency schedules. In the event of a fire or spillage involving dangerous goods, it is important that your onboard emergency procedures are followed closely. This is likely to incorporate the use of the EMS guide. But how is the EMS schedule used? The emergency schedule is used by following 3 steps. First, identify the UN number and proper shipping name of the goods. This will be found on the labelling and placarding of a tank container or from the special list or cargo manifest if packaged goods are in a container. Next, go to column 15 of the dangerous goods list and obtain the emergency schedule code for fire or spillage. Finally, go to the EMS guide for the appropriate fire or spillage schedule for action required to deal with the incident. Now that we know the process, let's consider an example. You are transporting a cargo of lead perchlorate solution, UN 3408, packing group 2, when leakage occurs. When we look at the dangerous goods list, we see that the EMS spillage code from column 15 is SQ. When we go to the EMS guide, we find this information when we reference the code. You can then follow the general guidelines and contact the superintendent or emergency contact person to obtain expert advice on dangerous goods response measures. In addition to responding to an incident involving dangerous goods, there are also several reporting procedures that must be followed. MARPL requires a report to be made when dangerous goods in package form are lost overboard, or probably lost overboard from containers and portable tanks, or there is a risk of them being lost overboard. There are 2 types of reports that might need to be made: a dangerous goods report and a marine pollutants report. A dangerous goods report must be made when there is an incident where lost packaged dangerous goods could endanger persons or the environment. A marine pollutants report must be made when those dangerous goods are marine pollutants. These are referred to as hazardous substances for reporting purposes. Go to Reporting Procedures Appendix Section 2 to see the standard reporting format and procedures in the supplement to the IMDG code. Where goods have been lost overboard, but there is no risk of further dangerous goods being lost, you need to complete the cargo details in section Romeo of the Dangerous Goods Report. However, if there is a risk of further dangerous goods being lost, or in the case of probable loss of hazardous substances, then you must also complete section Papa. Section Papa and Romeo require specific details to be entered. Both Papa and Romeo sections require the correct technical name or proper shipping name of the goods, the UN number, the IMO hazard classes, and the names of the manufacturers of the goods, when known, or the consignee or consigner. You must also identify the types of packages, including identification marks, and specify whether portable tank or tank vehicles, or whether freight containers or other transport units contain packages. This must include the official registration marks and numbers assigned to the unit. You will also have to give an estimate of the quantity and likely condition of the goods. With Section Romeo, you will also have to give information on whether lost goods floated or sank, whether loss is continuing, and the cause of the loss. The reports are made to the nearest local or government administrations for coastal states. The list of national operational contact points responsible for safety and pollution prevention response is kept updated by IMO circular 4 times a year. A copy of this needs to be on board and should form part of the ship's emergency response procedures involving loss of dangerous goods. As we have already said, dangerous goods can be harmful to human health, and so it is important to know how to respond in the case of a medical incident involving dangerous goods. Crew members may be affected by dangerous goods by inhalation of toxic or corrosive vapors, physical contact with or ingestion of hazardous materials. There are a number of signs that someone might have been exposed to hazardous substances, including breathing difficulties, confusion, chest pain, vomiting, shock, and bleeding. In these circumstances, you can find medical advice on board in the supplement to the IMDG code, in the Medical First Aid Guide for use in accidents involving dangerous goods. You may also find specific advice on emergency response after exposure to hazardous substances in the Dangerous Cargo Transport document. Let's take a few minutes to look at how to use the Medical First Aid Guide for use in accidents involving dangerous goods. This uses a simple 3-step process to identify the course of action to take. The first step is to identify the emergency action and diagnosis, using the decision tree. This gives ready reference to treatment tables based on the symptoms shown. You answer yes or no to a series of questions about the patient's observed condition. An answer no takes you to the next question down, where an answer yes takes you to one of 20 numbered treatment tables. Once you have found the right table, the next step is to identify the treatment table based on exposure to specific chemical types. Each table provides comprehensive details of treatment for various signs and symptoms. In some cases, this will include the follow-up treatment required. Lastly, you will use one of 15 appendices that provide general details of procedures for dealing with first aid injuries and emergencies associated with the contact of chemical substances. Appendix 15 provides cross-reference to treatment tables for specific substances that require special treatment based on their UN number and proper shipping name. Now that we know how to use the Medical First Aid Guide, let's consider an example. A crew member has reported that his hand is very red, swollen and painful, with significant blistering. On examination, it appears to be a chemical burn. The crew member has been close to a leaking container of UN 1790 hydrofluoric acid with more than 60% hydrogen fluoride. Our first step is to follow the emergency action and diagnosis to identify the appropriate treatment table. When we answer yes to has the skin been contaminated, this takes us to Table 8. Table 8 provides information on the treatment of skin exposure to chemicals. The treatment table also refers you to Appendix 8 for more specific treatments for dealing with skin exposure to chemicals. It also tells you to go to Table 16 if there has been exposure to hydrofluoric acid, as this is a chemical that is particularly corrosive to living tissue. In the event of spillage or leakage, you should always think safety first, and be aware that dealing with chemical fires or spillage requires specific procedures involving hazard protection measures. You must avoid contact with dangerous substances at all times and do not walk through spilled liquids, dust or powder. Keep away and upwind of any vapours or gases. If at sea and possible, turn the vessel so that the accommodation block and bridge is upwind. Follow the advice given in sections 6 and 8 of the safety datasheet, or follow the emergency instructions in the EMS guide or those provided by the consignor. Crew members must wear protective clothing suitable for contact with the hazards presented. They must also wear self-contained breathing apparatus. Finally, check with the IMDG code and your company response procedures for advice.